Adab, our honorable course teacher and everyone present here today. Welcome to our presentation on computer networking sessional. I am Tridib Chakroborty and along with my team member Nusrat Tahiat, we are going to present our project titled Design and Implementation of our Secure Digitech Network System, a multi-floor enterprise architecture for Redon Company Limited. In this project, under the guidance of our Department of Internet of Things and Robotics Engineering at the University of Frontier Technology, we simulated a highly secure hierarchical enterprise network environment designed to satisfy complex corporate guidelines. Before diving into the design details, let's look the primary objective of this project. The core objective of our project is to design, simulate, and validate a robust four-story enterprise network architecture for a high-value financial institution. To achieve this, our design is structured upon three fundamental pillars. First is structural scalability. We implemented a Cisco recommended three-tier hierarchical topology consisting of the core, distribution, and access layer integrated with OSPF version 2 routing to ensure subsequent path coverage and redundancy. Second, granular security. Because this is a financial firm, department isolation is non-negotiable. We utilize VLANs to logically segment traffic paired with layer 2 security measures like port security, HSS remote access, and credential hashing. Third, network automation and services. To minimize human administrative error, we centralized IP address management via dynamic host control and protocol, deployed secure localized corporate wireless network, and integrated enterprise web, HTTP, and mail services. The Redon Enterprise expansion. Let's look at the project scope. Our client, Redon Company Limited, is a banking and insurance firm expanding with a new regional branch. That here our challenge is we need to support approximately 720 endpoints across a custom four-story building, ensuring that sensitive financial transactions are securely isolated from public and guest areas. Our solution is we created a fully interactive digital sandbox using Cisco Packet Tracer to simulate the exact interference. As you can see on the right-hand technical parameters dashboard, our base network starts with the private IP block 192.168.10.0. We numerically applied variable length subnet masking to partition the range into 12 dedicated departmental virtual LANs. VLANs accommodating up to 60 users per subnetwork with zero address waste. The architectural framework and protocol foundations. To understand how the traffic flows, we adopted the classic Cisco hierarchical network design. At the core layer, we positioned high-speed Cisco 2911 router in a fully mesh topology. Their sole job is rapid, redundant packet forwarding. At the distribution layer, we used Cisco 3650 multi-layer switches. This handle inter-VLAN routing through SVIS, switched virtual interface, and enforced security policies. At the access layer, we deployed Cisco 2960 switches connecting the end-user PCs and wireless access points directly where handling broadcast containment. On the protocol side, OSPF version 2 dynamically calculates loop-free shortest path using the Dijkstra algorithm across the four routers. VLSM mathematically creates 26 subnets, providing exactly 62 usable IP addresses per department. VLANs prevent the logical routing weakness, keeping a guest user from ever sniffing financial packets. Here, our 4 by 4 architecture is the diagram illustrates our logical floor-by-floor architecture layout, color-coded for ease of audit. On the first floor, we have VLAN 10 for management, VLAN 20 for research, and VLAN 30 for HR department. The second floor hosts 40 VLAN for marketing, 50 VLAN for accounting, and 60 for finance. On the other hand, the third floor contains 70 VLANs for logistics, 80 for customer care, and 90 for guest area. Finally, the fourth floor hosts the vital VLAN 100 for admin, VLAN 110 for ICT administration, and our central database in VLAN 120 for server room. Here is our network topology and VLAN segment. We have configured the access point and DHCP addressing in the router, and in the router we have configured CLI within department and central router. We have configured the central routers. We have here is our router for routing table verification. We have WSPF and DHCP server pool in the router. We have in the server we have configured the hypertext transfer protocol, and we have configured email service. The rest will be conducted by my teammate Nusrat Tahiat.
I will explain the rest of the presentation. These are the screenshots of different steps for the input and output segments. We, we have conducted the ping test for connectivity proof of traffic generation in Cisco packet tracer. This is the simulation panel, and we have also conducted the HTTPS traffic to show a certain text from the web browser. And here is the trace route to map the path. We have also successfully generated multicast traffic, and this is the video table information. This analytical matrix outlines the core network engineering challenge we address. The subnet overlap vulnerabilities the subnet overlap vulnerabilities. A flat network causes IP conflicts. We mitigated this by mathematically implementing PLSM to segment the space into precise PLSM 26 blocks, granting exactly 62 usable hosts per department without this. And we have and in paper we can also encounter broadcast roles. Uh, the, uh, the 720 endpoints on a unified flat network generates a massive amount of background ARP traffic, degrading the overall bandwidth. So we deployed a layer 2 VLAN isolation combining broadcast logically to 60 user departmental silos. For the physical layer intrusion, any unauthorized individual plugging malicious laptops into corporate switchboards to seek financial profit. So we increased the port. So we implemented the port security so that rogue devices instantly disable the compromised port. Legacy management protocols Telnet transfer data in clear text. We replace them with RSA encrypted SSH and enforce password encryption globally. For the network performance evaluation or post-implementation evaluation programs, three major achievements. First, routing convergence is achieved. Our core network successfully converged using OSPF dynamic liquid cost. The network dynamically routes traffic and heals itself during its link failures. Second, security and isolation is validated. Financial departments remain completely separated from guest or public access. As a result, broadcast frames remain 100% confined inside specific VLAN boundaries. Inter-VLAN communication only occurs through the authorized default gateways or SPIs. Thirdly, the automated administration is optimized. A zero-touch IP provisioning for 700 plus devices were implemented. As a result, the end-user client devices automatically initialized via the centralized DSC, eliminating the manual administrative overhead of tracking static IPs and preventing duplicate IP errors. An honest engineering evaluation refers to analyzing both strengths and constraints of the design. We achieve robust fault tolerance using dual multi-layer distribution switches paired with mesh core routing. Establish granular edge security through switch level port protection. The network is also highly scalable. Any new departments can be added dynamically with minimal core configuration changes. However, we have two limitations. Single point of failure for DSCP since all DSCP ports run on a single physical server in VLAN 120. A server crash will freeze IP provision across all the ports. And the absence of perimeter defense. The design lacks dedicated edge firewall details to monitor external WAN traffic or protect against DDoS. This brings us to the conclusion of our project. In conclusion, the secure Digitech network system successfully translates theoretical network concepts into a practical multiple enterprise infrastructure tailored for real company limited financial operations. By strictly adhering to Cisco's hierarchical lifecycle models, this project delivers a highly segmented logical architecture that safely isolates sensitive departmental data and a self-cleaning routing backbone that ensures maximum uptime and dynamic traffic for corporate service, and a modernized security posture that hardens the network against internal physical tampering and remote external eavesdropping. Ultimately, the simulation proves that the proposed architecture is viable and secure for immediate corporate deployment. For the future generation enhancements, we are going to at phase one, we are going to implement high availability and automation by deploying redundant DHCP servers with H8020 failover scoping. We can also implement hot standby routing protocol for gateway redundancy, eliminating single points of failures at the distribution layer. For phase two, we can implement on cybersecurity perimeter and edge by restructuring access control lists to strictly block guest zone routing to corporate server, and by integrating a dedicated firewall and AI-based intrusion prevention system for automated anomaly detection. This will increase the security system greatly. And at phase three, we can implement cloud and enterprise wireless capability. The transition from autonomous APs to centralized WAN, leveraging data authentication. By this we can integrate a cloud-based monitoring system. These are the references and these are the references we use for the help of this project. Thank you everyone. That is all.